So let's continue on. We're continuing with using Avogadro's number as a conversion factor. In the previous video, I gave you 2 moles and I told you to convert that to atoms. I said you have 2 moles of hydrogen. How many atoms of hydrogen is that? Well, now we're going to say we have particles. Let's say we have 2.35 times 10 to the 20 molecules of water, and I want to know how many moles of water that is. So I'm going to use Avogadro's number as a conversion factor. What is Avogadro's number? 1 mole is 6.02 times 10 to the 23rd. Okay, so we're going to write 2.35 times 10 to the 20 molecules. They're of water, but that's okay if we don't write that. And what are we going to cancel? We want to cancel out molecules and we want to end up with moles. So we go 1 mole is 6.02 times 10 to the 23rd molecules. How did we know that? Because we have that memorized. That's your Avogadro's number conversion factor. 1 mole is always 6.02 times 10 to the 23rd anything. Molecules, ions, atoms, glasses, Coke Zeros, whatever. When you say the term mole, it means 6.02 times 10 to the 23rd. Okay, so your molecules are going to cancel. And now we need to put it into the calculator correctly. And this is where it gets a little tricky. If you guys are using this type of calculator where the caret button, remember what I told you guys in a previous video. Anytime you have exponents in the denominator, you must, and I repeat, must, use parentheses around the whole number. Or else your calculator is going to think you are dividing this number, and then you're going to be multiplying that one on top. So always put parentheses around the whole number in the denominator. Okay, so we're going to plug it into our calculator. We've got 2.35 times 10 caret 20. Okay, now I'm going to divide by, I'm opening up parentheses, 6.02 times 10 caret 23, and then I close parentheses. Okay, and I press, and then I get this number 0.00039,039. Okay, so I switch it over to scientific notation. You can do that quickly on your calculator, or you can do it yourself, obviously. And this is 3 sig figs. This is what's limiting me. So I'm going to limit it to 3 sig figs. It'd be 3.90 times 10 to the minus 4 moles of water molecules. Okay, so that's what you should be getting. All right, now if you're using the other calculator that has the EE button, what would you do? You would put in 2.35 EE20. Remember what I said in previous videos, you don't put the 10 there. So 2.35 EE20, and then you say divided by, you don't have to use parentheses when you use the EE, but if you want to just to make sure, that's fine. So you say divided by open parentheses 6.02 EE23 close parentheses. Do not, and I repeat, do not use the 10 if you are using the EE button. Okay? All right, so we learned how to use Avogadro's number to convert between particles and moles and particles. Now we're ready to move on to figuring out how to use molar mass. And then we're going to combine the two. So the next few problems won't be using Avogadro's number as a conversion factor. We're going to use molar mass as a conversion factor. We're going to use molar mass as a conversion factor. And it's a perfect conversion factor because the units of molar mass is grams per mole. So 1 mole is equal to this many grams, or this many grams is equal to 1 mole. So let me show you what I mean by that. Let's say you've got 10 grams of water, and you want to know how many moles is that. Okay, so what you want to do is you want to convert between grams and moles. In order to convert between mass and moles, or moles and mass, you need molar mass. You don't need Avogadro's number. Avogadro's number is only used to convert between particles and moles and particles. But in order, whenever you've got grams, whenever you've got mass, you're going to use molar mass, okay? Anytime I give you mass, you have to use molar mass. If I give you moles, you see what the question is. If I'm looking for mass, you use molar mass. If I'm looking for molecules or atoms or ions or whatever, you use Avogadro's number. So right now I gave you mass, so you have to use molar mass. What is the molar mass of water? You go calculate it. So you have to find, number one, you need to find the molar mass of water, which we did in a previous video. Remember, we said we have hydrogen is 1.01, the other hydrogen is 1.01, oxygen is 16.0, and we ended up with 18.0 grams. Remember, not AMU, because if we're talking about molar mass, we're assuming we have a mole of water. So 1 mole of water weighs 18.0 grams. So now my setup, I'm going to erase all this and say, okay, so they gave me 10 grams of water. I want to go from grams to moles, because that's what the question was. It's like, how many moles is that? Remember dimensional analysis. The unit that you want to get rid of, you set it up so that you can cancel. The unit you want to end up with is what is going to be on the top. All right, so we know that 1 mole of water is 18.0 grams. Notice I did not use Avogadro's number here. Avogadro's number is used when you're converting, like I said, moles to molecules, molecules to moles, atoms to moles, stuff like that. But when you're given mass, you have to use molar mass. All right, so we can cancel out the grams. We get our calculator, 10 divided by 18, 10 divided by 18, rounded to the right number of sig figs. How many sig figs should I round it to? 3, since this is 3. My calculator says 0.55555, etc., etc. So I'm going to go with 3 sig figs, so 0.55. And then since the one after this is a 6, sorry, is a 5, we round up, so this ends up as 6. So 0.556 moles of water. Okay, I'm going to be attaching a worksheet for you guys to practice with. And honestly, the only way you can get really good at molar mass and Avogadro's number as conversion factors is to just keep on practicing. Okay, keep doing this over and over again. All right, let's do one more, and then we'll combine Avogadro's number with molar mass to do a bigger problem. So let's say I have 2.50 moles of sodium chloride. And I want to know how much does that weigh? All right, so look at what I'm asking. I'm asking for mass. So anytime you see mass in the question, whether I'm looking for mass or I gave you mass, you're going to use molar mass. Okay, you're not going to use Avogadro's number. So you've got 2.50 moles, and you want to go to grams of sodium chloride because that's what weigh is. So we're going to put moles down here and grams up here. Why are you putting moles down here? Because that's what you want to cancel. Why is grams up here? Because that's what you want to end up with. Okay, anytime you see moles and grams as a conversion factor, that is molar mass. How do we get molar mass? We go to the periodic table. We see sodium on the periodic table is 23.0 grams. Chlorine on the periodic table to 3 sig figs is 35.5 grams. I have these memorized, but let me just make sure. Obviously, you don't need to memorize any of these masses. So it's 35.45. I'm just going to round it to 35.5 so that I can have 3 sig figs. Okay? All right. So we add these up together. 58.5 grams. So the mass of 1 mole of sodium chloride is 58.5 grams. You go 1 mole, 58.5 grams. Moles cancel. All right, we pick up our calculator again, which is right here in my hand. 2.5 times 58.5, and you end up, your calculator says 146.25 grams. Now you can't report all of that because we're limited by sig figs. The given number here, the measured number was 3 sig figs, so I need to round this to 3 sig figs. So I'm going to have to cut it off right here. This is not a 5 or higher, so I'm going to round it to 146 grams. So that means if I have 2.5 moles of sodium chloride in an experiment, I need to weigh out 146 grams. Okay, good. So in the next video, what we're going to do is we're going to maybe start off with grams and then switch it to moles and then switch the moles to atoms or molecules. Or start off with molecules, switch them to moles, and then switch it to grams. So we're going to be using both conversion factors that we just covered, Avogadro's number and molar mass, together, one after the other, in order to do a bigger problem. Okay, good.